This will be my solution on 2021 AAHL time zone 1 paper 2. Okay, if you need paper 1, I'll link it below. If you have not tried the paper and you can't find a link, you probably would have a difficult time finding. You can take a screenshot right now for the questions. So question 1, continue here. Then question 2. So let me see, 1 and 2 are shared with SL. 3 is also shared. 4 also shared. 5 also shared. So 6 is really an eggshell question. 7, eggshell question. 8, also an SL. An eggshell question. 9. 10 is shared with SL. This is the first question of section B. Alright, this is 10 continued. Then 11. And lastly 12. Okay, so my solution starts now. Some scatter diagram. You ask to find the regression line. So this is something your calculator would handle. So you should figure out how to do it on your calculator. It's probably in statistics or spreadsheet. Alright, just input all of them. And then use the linear regression function. So it's the first question and also a question shared with SL, so you really should not lose any mark here. And well, you probably won't if you know how to use your calculator. Right, so I'll do stat. So I believe for my calculator, this is where they give you A and B. So I believe you would get A being 0.433 and B is 4.5. Okay. So predict what happened when x is 18. You simply substitute 18 into the equation and press calculator for the value. Let's say we won't do that. Find the mean of x and mean of y. Alright, x bar is the mean of x. So if you have done 2 variable stat on your calculator, you would get that as well. If not, just find the mean of x again. You should probably get 15 and 11. Lastly, draw the line of best fit. So the idea is the line of best fit have to pass through the mean point, which is this 15, 11. So usually we go to the picture, mark the point 15 and 11, and then we circle it to represent that that's the mean. And then the y-intercept was 4.5, so B use the y-intercept, so we go to 4.5. And then you join that 2 point with a ruler, then that would give a pretty accurate drawing of the line of best fit. Okay. Question 2. Quite a simple normal distribution question. So they give you the mean, give you the standard deviation. The thing is rejected if it's less than 995. So x is normal with mean and variance. So the probability that x is less than 995 would be a simple calculator thing. You would probably do something called normal CDF. The calculator I have here is a bit unusual. Most graphical calculator that IB students use doesn't look like this. So if you have 100 bag estimate how many of them would be rejected. So that's simply 100 times the probability that you reject it. So it's about 6.66 of them. Alright. Expected value doesn't have to be a whole number. Then we have a given problem. So you're supposed to use the conditional probability formula, which is provided. B is the given thing. Okay. So the formula goes A intersect B over the probability of B. So in here, A is what they want. They want it to be greater than 105, given. What's the given thing? The given thing is that the thing is not rejected. It is rejected if it's less than 995, so it's not rejected if it's bigger than 995. Alright, then you have A intersect B over the probability of B. So if you think about it, the probability of x being less than 995 was this. So for bigger, we have 1 minus that. And over the top, you need to figure out the intersection of these two events. Intersection really means and. So we have x being bigger than 105 and x being bigger than 995. Does really mean x is just bigger than 105, because if you're bigger than 1000, you're automatically bigger than 995. So this is also something your calculator will do. Normal CDF, you make the lower bound 105. My calculator can't do lower bound, so I'll have to do 1 minus. Then you press calculator, whatever that is, that's the answer. Then we have a Ferris wheel. This type of question was kind of uncommon in Excel. They probably think it's too easy. But since now Excel would share question with SL, and this is very popular with SL, so maybe it would occur quite a bit for HL as well. So in case you're not familiar, when the points go around the Ferris wheel, and if you graph the height of that point, it would trace out a sine graph or a cosine graph. In this question, they want to use a cosine graph. They're really the same, right? For this question, the point start from the lowest point. So start from here, then go up, come back down. Alright, so according to the question, this is 10. The top is like 10 plus 110, so 120. The period, so complete one revolution in 20 minutes. So this is 20. So you should know that A gives you the amplitude of the graph, because A is a vertical stretch, and the amplitude of the original cosine graph was 1, right? So if you stretch it A times, the amplitude becomes A. So keep in mind that amplitude is measured from the middle line, so it's like the middle to the top here. The middle is obviously 65, right? 120 plus 10 divided by 2, so go up 55. So A is 55. Right, except a cosine graph should start from the top and go to the bottom. This one is reflected along the x-axis, so we need a negative. B, to find the value of B, alright, the original period of cosine is 2 pi. So if you multiply by B, it will be horizontally compressed by B times, so the period would become 2 pi over B. But now the period is provided as 20, so B is 2 pi over 20 pi over 10. And lastly, C is how much you shift up, right? So the middle line would shift up by that amount, which now is 65. So C is just 65. Then a kinematics question. So the key of this question is everything could be done with a calculator. Alright, find the time when the particle is at rest. That's when v is 0. So they gave you the v, so you graph the v. Alright, so let's graph it. So it's x times I, x minus 3. So is my calculator in radian? So obviously kinematics have to be in radian. So graph again. I think I'll have to set my window. So you can probably use what they give you. So 0 to 10, 0 to 10 for x, negative 8 to 6 for y. So yeah, good enough. Then we will find the x-intercept, the first one. So the answer of A would be 6.74. B, find the total distance traveled. So you just add up all the area, but since it's a distance, even for area under the x-axis, you would add it as a positive. Right, so that's also something your calculator should be able to do. So you should kind of figure out how to do integral with your calculator. So like a lower bound, so we'll pick 0. Select an upper bound. So let's say I want to go to this point, which was 6.74. Okay, this is where I realized I should have used more decimal place. Maybe you should. So obviously the calculator would say it's negative, but we will take the positive value. Then next we'll do it again. Find integral. This time we start from 6.74 to the next intercept, which I didn't find. Maybe I should find it first. Find the second x-intercept, which is 9.088. Okay, so do that again. Integral from 6.74 to 9.088. I get 7.4717 plus the last bit, which go from 9.088 good to 10, because the question only go up to 10. So 10. Obviously, we add it as a positive again. Alright, so add them up. That's what you got. Then the acceleration. So you want, acceleration is the derivative of v. It's like the gradient of the vt graph. So we want to find the gradient of this curve when t is 7. Again, that's something your calculator can handle. My calculator have an option of just show derivative. Yours probably, like next to where you do integral, there should be a thing that show you the derivative. So you do that, and then like tell him you want x to be 7. Tell the calculator you want x to be 7. So the gradient at that point should be 5.93. Okay, so the key of this kind of question is the fact that the calculator would do everything for you. Alright, otherwise it will take you quite some time to do it yourself. Right, for example, can you integrate that thing? Well, yeah, you can do by part, but that take way longer than 2 mark. Okay, maybe not that long, but still, it's not worth your time. Can you differentiate that by yourself? Product rule, yes, but same idea. Then we have a, I think this is the last question that you shared with SL. Is actually quite a dumb question. The only trick is instead of just make it some sort of power, they have to make it n plus 1. If you think about it, it actually makes no difference. Like, this is totally unnecessary, right? The thing you do where the power is just m is basically the same. So you could have do it this way, find a value of m, and then just take one away. That would give you the value of n. But I guess we'll play along and actually do it the difficult way. So we just do the normal thing, right? The general term is like NCR a to the power of n minus r b to the power of r, except our n is n plus 1. So it should be obvious that r should be 2 in order to get x to the power of 4. So NC1 n plus 1 C2 times 3 n plus 1 minus 2 should equal to 20412. Coefficient doesn't count the x. So we'll have to simplify the NCR using the NCR formula, right? If it's NCR, then it's n factorial over r factorial over n minus r factorial, right? So it's n plus 1 factorial over 2 factorial over n plus 1 minus 2 factorial times 3 to the power of n minus 1. Alright, obviously n plus 1 minus 2 is n minus 1. So n plus 1 factorial is n plus 1 times n minus 1 factorial, n minus 1 factorial. So they cancel out. Right. Okay, this is where you use your GDC. So this is one of the things of paper 2, right? You need to know when you can stop and simply use a GDC. So n plus 1, I better bracket that, times x over 2 times 3 to the power of n minus 1. Okay. And that will be 20142. So we plot it, and we'll have to change the window a little bit. Oh, they did it for me. Calculate. No, that's not what I want. Find intersection. So is 6.99. I believe that means 7. So n is 7. It's a bit disappointed that it doesn't give me exactly 7. It's a bit weird, but I guess 7 work. Well, just in case, let's check. So what? 7 plus 1 is 8 times 7 over 2 times 3 to the power of 7 minus 1 is 6. Wait, I typed the wrong thing. This is outside. 3 to the power of 6. Yep. That. Wait, did I copy the question wrong? Oh yeah, that's why the calculator gave me a slightly different value. Okay, my mistake. Okay, finally we have a worthy question. Finally an actual question with two planes in Cartesian form. So what will be a third plane which will be perpendicular to both plane 1 and plane 2 and pass through the origin? And they want the Cartesian form. So this is the thing about vector equations of plane and lines. You need to be familiar with how to convert from one form to another. So in this case, you need to know how to get the Cartesian form. You probably know Cartesian form come from the normal form, which look like n dot r equals to n dot a, where n is the normal vector of the plane, which is a vector perpendicular to the plane, and then a is a particular point on the plane. A is like the position vector of that point on the plane. So usually we need to look for the normal vector first. Okay, what do we know? We know that plane 3, so say this is plane 3 should be perpendicular to both plane 1 and plane 2. Well, then the normal vector would be a vector that is perpendicular to plane 1. The normal vector of plane 1 would simply be the coefficient in the Cartesian form, so 3, 2, 1. The normal vector of plane 2 would be 1 minus 2, 1. Well, since plane 3 is perpendicular to both of them, plane 3 would basically be parallel to both of them. Right? That means they would be the direction vector of plane 3. They will be vector that go along the surface, the direction of the surface of plane 3. That would mean the normal vector of plane 3 can be obtained by doing the cross product of the two direction vector. So there are a lot of different ways of doing cross product. One way is you could just go to the former bullet and follow. So I'll do it my way. You can do it your way. At the end, you should get the same answer as me. So it's 2. So I've got 4. And then 3 minus 1. So 2, negative 2. And then minus 6, minus 2, minus 8, I think. Okay. So for a direction vector, a normal vector, where you only care about the direction, you can take out a common factor, wouldn't affect anything. So we can take n to be 2 minus 1 minus 4 dot r, we write it as x, y, z, equals to n dot a. A is a point on the plane, so it says the plane will pass through 0, 0, 0, so we'll take that to be a. Anything dot 0, 0, 0 is 0, so this is 2x minus y minus 4z equal to 0. Okay. Then they want the coordinate where the three planes intersect. Normally you would do row reduction, but now this is something your calculator can do. Alright, that's why it's 2 mark. It's not worth actually doing it yourself. So what you do is, it depends on how your calculator do it. So usually is around the numerical solve or the solver or the end solve thing. It's called solving system of linear equation. So you type in the two equations. So it's what? 3x plus 2y plus z to 2y plus z equals to 6. What else? X minus 2y plus z is 4. And also 2x minus y minus 4z equals to 0. Then you just choose solve. So that should be the answer. They want the coordinate as a point, so you would write it horizontally. That's it. This one is a continuous random variable. Part A, it says nothing, but just show this. Oh, since they didn't say anything, I guess we'll use the only thing we know for a random variable, the fact that the total probability have to be 1. So I'll probably integrate the thing from 0 to 4. Because for a continuous random variable, integration gives you probability, and the total probability should be 1. So I guess it comes down to whether you know how to integrate this. If you want to try, you should, and somehow you haven't, you should pause the video now. Alright, otherwise, this is a substitution. So there are different ways of doing substitution, so you do your way. Should we change the limit? Well, let's do that. When x is 0, this is k. When x is 4, this is 16 plus k. The limit, So this is k, 16 plus k, and then u cube over 2, I think. U over 2. Right. It's just a substitution. Use your own way. So we have, take the half outside. This is u to the power of negative 3 over 2. So we integrate that. It becomes, wait, I will integrate, so I don't need to write the integral sign anymore. Negative half over negative half. Well, remember this all equal to 1, okay? So well, that's right here. So the half cancel out. So it's negative u minus negative, put k in. That equal to 1. So what's that? Negative 1 over square root of 16 plus k plus 1 over root k. That look like what they want. Pretty much. I think they get a common denominator on the left. And then multiplied the bottom to the right to get what they want. Okay, then they want the value of k. It pretty much means solve this, and that's pretty much the job of the GDC. Okay, so let's do that. What's this? Square root 16 plus x minus square root of x. Need another function. So square root k, square root x times well, it's okay, it's the same. Plus x close bracket. Let's do that. I'll need to it automatically do it for you. I don't know if your GDC can do that. Then you have to set the window yourself. Find an intersection. 0. So b k equal to 0.645. That should do the job. I believe this would be the last question of section A. Oh, there's actually 2 more. Okay, quite long. Question 8. So they want to find the modulus and argument of z times w. So it should obviously be de Moivre's theorem. Okay, I probably say the name wrong. But you know, when you multiplied 2 complex numbers in polar form, you multiply their modulus and add their argument. Now the trick of this question is w is not exactly in polar form because technically this cannot be a minus. So you have to change w a bit. So what happens is you can like put the minus into the sign, because it happens that if you sign a negative angle, it will be negative side of angle, right? Like sine minus theta is negative side of theta. But for polar form, the 2 angles must be the same. But turn out for cosine, you can add a negative if you like. I don't have enough space because cosine negative theta is just cosine theta. Alright, so to write w in proper polar form, the argument should be negative 2k pi over 5. Right, then the modulus of wz would just be the product of their modulus, so it's 2 times 8. But the argument would be adding them up after we have write it in polar form properly. So it's like pi minus 2k pi. So that's like 1 minus 2k pi over 5. Then it is supposed that z times w is an integer. Yeah, you should note that integer also mean integer is a subset of real number. So if you are an integer, you also have to be real. So I guess to find what's the minimum value of k, we'll use the fact that it's real, which means the imaginary part should be 0. Okay, let's actually write out z times w. It will be 16 cosine the argument plus I sine the argument. So in order for this thing to be real, you need the imaginary part to be 0. So psi 1 minus 2k pi over 5 have to be 0. Then you think psi what give you 0? Well, then like psi 0 gives 0, psi pi gives 0, 2 pi gives 0, so on and so forth. So this thing inside must be a multiple of pi, right? Where n is an integer, it could be negative, right? N could be negative. So we cancel out the pi. That means 1 minus 2k have to be 5 times an integer. Then minimum value of k. Okay, it did say k itself have to be a positive integer. So k itself have to be positive. Then what can we do here? We can do like 1 minus 5n equals to 2k. So k is 1 minus 5n over 2. So we need the smallest positive number that can be written in this form. Right, so we need this to be positive. We also need this to be an integer. So you can think like, what could this be? Well, 5n has to be like a multiple of 5. So it could be what? It could be 0. 0 is a multiple of 5. 5 times 0 is 0. But then with 0, k is a half. That's not an integer. And then since you want k to be positive, n itself probably have to be negative. So maybe n is negative 1. Negative 1 times negative 5, that's like plus 5. 1 plus 5. 6 over 2 is 3. Okay, that's probably the smallest one. Okay, so the minimum k is 3 if k have to be a positive integer. Now then, remember that zw as a whole has to be an integer, so the real part also have to be an integer. So does this make the real part an integer? So if you put it here, you have what? 1 minus 6, because 1 minus 2k, right? 1 minus 2k pi over 5, so that's like negative pi, cosine negative pi, that's negative 1, so zw becomes negative 16. Okay, that works. 16, negative 16 is an integer. The question didn't say wz has to be positive, so negative integer also work. So, oh, that's exactly I. So it's negative 16, and minimum value of k is 3. Okay, a bit tricky. That should be, oh no, that's not the end of section A, so we'll keep going. Some bolt, initially B is 50 meter due east. Distance travel x and y, the angle of the bearing is theta, so this angle is theta, blah blah blah. Find this. Okay, may not be obvious, but once I told you, it should be, you'll find it easy. So this is like y minus x, and this is like 90 minus theta. So we have tangent 90 minus theta equals to y over x over 50. But if you know tangent 90 minus theta is actually cotangent theta. I mean, if you don't know that, you can basically think if this angle is 90 minus theta, then this is theta, right? Then if you tangent that, tangent theta, you get 50 over y minus x. So you 1 over both sides, right? 1 over cosine, 1 over tangent is cotangent, right? So you get the same thing. This is basically the proof that tangent 90 minus theta is cotangent theta, right? It's just because, well, it's just because if this is theta, this would be 90 minus theta. Then we multiply the 50 to the other side. The y minus x, so we move the x, you get what they want. Wow, that's so much for 1 mark. B. So I see the word rate of change. So this is probably a related rate question. Rate. Find the speed of boat A. So that's like how fast both A go. You think about it. X is the distance that both A have go. The derivative of distance is speed, right? So we're really looking for dx dt. And then boat B is traveling at a speed doubled of boat A, so that probably means dy dt. dy dt equals to 2 times dx dt, right? Because the speed of boat B would be dy dt, because for B the distance is y. That would probably means we should differentiate this. So we would basically be like differentiating this implicitly with respect to time. So if you differentiate y, you get dy dt. If you differentiate, oh, that's a t, dy dt. If you differentiate x, you get dx dt plus 50. Differentiate cotangent theta is negative cosecant square. That's provided in the formal booklet. Then you chain rule, so times differentiate theta, that d theta dt. So now what? So we have dy dt equals to 2 dx dt, so there's 2 dx dt. Put the negative in front, 50 cosecant squared theta times what? The theta dt, well, that's the rate of change of theta, right? So it's negative 0.1. So we subtract this to the left hand side. Dx dt would be minus 50 times cosecant squared theta times negative 0.1. So it looks like we need to find the value for cosecant theta. We'll be using the information that at that time, boat B is 10 meters ahead of A. So that would mean like this is 10, right, at that time. So what do we need, right? We need like cosecant theta. Cosecant is what? 1 over sine. Sine is opposite of hypotenuse, so this is hypotenuse over opposite. So we have to do Pythagoras, right? Root that plus 10 square. That's like what? 2,500 plus that plus 100, root 260. So that's like root 260 over 50. Right? So we put that in, we square that. So it's 2600 over 50 squared. 50 squared. So we have what? They cancel out. 1 of the 50 cancel out. 0.1 cancel 1 of the 0. So it's 260 over 50, which give us 260 over 55.2. So that should do it. Yeah, not bad. This is probably the most complicated related rate question in IB. Well, we'll continue section B in the next video.